AP Stats Quideo 4 is about 2 antibiotics that are available for treatment for a common ear infection in children. So it says that antibiotic A is known to effectively cure the infection 60% of the time, costing $50, and antibiotic B is effective 90% of the time, and it costs $80. So they have 2 treatment plans. The first one is that the treatment starts with antibiotic A, and if that's not effective, then they treat with antibiotic B. And then the second plan is that they first treat with antibiotic B, and if that's not effective, they treat with antibiotic A. So the first question asks, what is the probability that plan A will cure the child? So the way I organized it is in a tree diagram. I think this is the best way. A Venn diagram wouldn't work because they're not independent, as well as a two-way table, and it wouldn't work because they are independent and they're mutually exclusive. So you have treatment A. So they start with antibiotic A, and then so antibiotic A works 60%, and antibiotic B, and antibiotic A doesn't work is 40%. So then if it doesn't work, you have to use antibiotic B, which works 90% of the time, and it doesn't work 10% of the time. So it'd be like the probability of A plus the probability of not A times the probability of B. So you do the 60% plus the 40%, because if it's not working, but you have to use a 60 in case it does work the first time, times the probability of B working. So you got 0.96, and then it asks, it asks about using plan 2, what's the probability that would be cured. So you kind of do the same thing. You start with antibiotic B, which is the probability of it working, so you have the 0.9, and then use it antibiotic B not working times A working, which is 0.6, so you have 0.9 plus 1, which is also 0.96. So you have the same probability of both treatments. So the next question asks pretty much how much each plan costs. So it said that antibiotic A cost $50 and antibiotic B cost $80. So if plan A, if it does work, then you just have the $50, so you do 0.6 times 50, but then you need to add in case it doesn't work, so you do the 0.4 times 50 plus 80, and that equals $82, and use the 80, which is how much antibiotic B costs. So then treatment 2, use the 0.90 times $80, so that's probably to be working times how much it costs, but then in case antibiotic B doesn't work, so you do 0.10 times, that's the cost of A, 50, plus the cost of B, and that equals $85. So then last question is based on the results, which plan would you recommend? And I would recommend treatment A because they have the same probability of working, but treatment A is cheaper by a couple dollars, but it's still the cheaper value. And if it does work the first time, that means you'd only have to spend $50 because there's that possibility of still working.